Okay, now we'll come back to the second part of the video. We're going to solve the, if you remember, we're going to solve the material balance problem that involve multiple units. If you can recall that there are two actually distillation column, okay, which we have three components: xylene, benzene, and toluene. Okay, and then the top of the overhead product from the first column will enter the second column, and then you will have another product which is benzene at the top with toluene, and then you have xylene, benzene, and toluene, which is largely will be toluene here. And in the first column, you're gonna have xylene as well as toluene. There is no benzene here. Okay, benzene will go to the top, okay, together with toluene, and then together with little bit amount of xylene, the trace amount of xylene, which will be separated in the second column. Here, if you can remember that we have three, altogether we have defined the unknowns for distillation column 1. So for column 1, we have, okay, we have unknown which is the N2, right? N2, and then it is N3. We also didn't know what is N3. Okay, we know what is specified here. Xylene is 98%, toluene is 2%, but we didn't know actually the top one, which is XB2 and XT2, represent the amount of the mole fraction of benzene and toluene in the second stream, which is in N2 stream. That is the first unknown, all the unknowns in column 1. In column 2, okay, we have also several unknowns, which is we didn't know what is N4, we didn't know what is N5, and we also didn't know what is the mole fraction for the xylene, benzene, and toluene at the bottom distillation column, because at the top of the second column, we know that there is 94% of benzene and 6% of toluene. Okay, so we also didn't know XB5 as well as XT5. Just so you know that in order for us to calculate the mole fraction for xylene, is just 1 minus, if let's say you want to calculate the xylene here, it is just 1 minus XB2 plus 1 XT2. Okay, and then at N5 is also the same, which is the summation of XB5 and XT5. So you take 1 minus this, and then you will get the mole fraction for xylene. So that is quite simple. Okay, so the other additional information that you were given is that the amount of xylene that you recovered here, okay, in the first column at the bottom product is actually 96% from the feed itself, and the amount of benzene that you recovered at the top product in the second column is actually represent 97% of the feed that you put in. So the amount that you put in here, xylene is actually 45, benzene is 30, and toluene is 25. Okay, and we assume here is that because it's not given, we assume that the molar flow rate of N1, we put some basis which is equivalent to 100 mole per hour. Alright, so how are we going to solve this? First of all, we need to actually come out with the independent equations. Independent equations such as in column 1. So what will be the independent equation? First of all, we need to write, okay, column 1. Alright, so first of all we need to write what is the overall balance. So overall balance here is actually 100 equals to N2 plus N3. Right, and then what will be the second equation? Maybe we can write something on the benzene balance. How about benzene balance? So we have here actually 30. Okay, where does the benzene go? It doesn't go to the bottom, it just only go to the top. So we have here XB2 N2. Okay, so whatever that benzene you have here, it goes to the top, XB2 N2. So that is your benzene balance. How about your toluene balance? Okay, so toluene balance here, you have, let me put here, it's actually 25, okay, equals to xt2 N2, okay, which is the top product, plus the some amount of toluene at the bottom, which is 0.02, okay, multiply with N3. So this is your toluene balance. Okay, so we're going to look at the recovery factor later on. Okay, recovery factor is that we were told in terms of the xylene itself, okay, that is 96% recovered here. So we know that xylene recovery, okay, so what is the equation involved? So we know that 0.96% of xylene, okay, of xylene, which is out of 45, actually went to the bottom column here. So it is actually equals to 0.98 times with N2. So you should be able to look at this as the equation to really see that, okay, 96% from the amount of the actual xylene is actually being recovered at the first column bottom product. So that is column 1. Column 2. So what is the overall balance? So overall balance is N2 equals to N4 plus with N5. Okay, because we are taking at this boundary only. We don't talk about first column. We just talk from the feed that is entering the second column, and then we took at the benzene's balance. So benzene balance is actually XB2 N2 equals to, okay, we know that some of the benzene goes to the top, 0.94 N4 plus with, there will be at the bottom, which is XB5 N5. Okay, so as for toluene, then we have, for toluene here is actually XT2 N2 equals to 0.06 multiply with N4 plus with XT5 N5. Okay, another missing things that we need to include is, which is benzene recovery. Okay, benzene recovery, we were told that 97% of the benzene is actually goes to the top of the second column. So we know that 0.94 multiply with N4 is actually equals to 97%, which is 0.97 from the total amount of benzene. Okay, so now you can see that once you write down, okay, once you write down the xylene recovery and benzene recovery, you'll be able to straight away calculate, okay, I should be able to get the N2. Here, with benzene recovery, I should be able to get N4. So when you substitute N2 here, then you'll be able to know what is XB2. When you substitute N2 here, you'll be able to know what is N3. Okay, and whenever that you substitute N3 and N2 here, then you'll be able to resolve your XT2, okay, which is the toluene in the overhead product. Okay, so from that, at the same time, you can also determine, okay, from the benzene recovery equation, you can know what is N4. So you can substitute in this particular equation, and then you can determine your N5. And if let's say once you know your N2, your N4, your N5, okay, so you can actually determine what is your XB2, what is your XB5, everything can be solved immediately. Okay, so these are actually the way how you solve the material balance for multiple units. I hope that you'll be able to try it on your own, and then try to solve this problem. And I think it is really satisfying for you trying to do it on your own and get the right answer for you. So stay tuned for the next video. Thank you very much, and see you again in the next video. Bye bye.